In this module, we are going to start a new chapter of chemistry, that is chapter 2, is matter around us pure. In this, we will know how to separate many mixtures from a given solution or material. Introduction about the chapter. In this chapter, we are going to see how we can separate many mixtures. We are going to see a vast definition of the introduction on the suspension, colloids, and other solutions, etc. Introduction. Have you ever judged whether milk, ghee, butter, salt, spices, minerals, or juices that we buy from the market is pure? Have you ever noticed that pure word is written on everything which is packed? For common meaning, pure means no adulteration. Adulteration means any unorganized substance put inside any material which is not useful. If something is pure, then it means that its constituent particles of the substance are same in the chemical nature. As we see around, the most of the things are made of the mixture. What is mixture? Mixture are constituted by more than one kind of pure form of matter known as substance. A substance cannot be separated into other kind of matter by the physical process. It can be done only by the chemical process. Types of mixtures: homogeneous mixture, heterogeneous mixture. Homogeneous mixture having the uniform composition, for example, sugar in water, salt in water, sulfur in carbon disulfide, water and alcohol, etc. Heterogeneous mixture, non-uniform composition, for example, sand and salt, sugar and salt, wood, blood, and etc. This is the following process of filtration by which any material can be filtered with the help of a filter paper. This is the method how to use a filter paper and the process of filtration. What is solution? A solution is a homogeneous mixture of two or more substances. Lemonade, soda, water, etc. are the examples of solutions. As we think only liquids as solution, but solids have also a solution, as well as all type of solution. Gas have also a solution, as air is also a solution. A solution has two components, that is a solute and a solvent. The components of solute that dissolve the other component, it is usually present in a larger amount, is called solvent. The component of solution that is dissolved in the solvent, usually present in lesser amount, is known as solute. This is the following reference image for the solution. Here you can see that there are many solutions which are given in the color of blue, yellow, green, blue, etc. red. Properties of solution. A solution is a homogeneous mixture. The particles of solutions are smaller than 1 nanometer, that is 10 to power minus 9 meter in diameter, so they can't be seen by naked eyes. Because of smaller particle size, they do not scatter a beam of light passing through the solution. Path of light is not visible in solution. The solute particle cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed, that is, solution is stable. Our next topic is concentration of solution. At any particular temperature, a solution has that dissolved as much as solute as it is capable of dissolving. It is said to be saturated solution, or in other words, we can say that when no more solute can be dissolved in a solution at a given temperature is called a saturated solution. The amount of solute present in saturated solution at this temperature is called its solubility. The amount of solute contained a solution is less than the saturation level. It is called an unsaturated solution. The concentration of the solution is the amount of solute present in a given amount, that is mass or volume of a solution, or the amount of solute dissolved in a given mass or volume of solvent. Concentration of solution is equal to amount of solute upon amount of solution, or concentration of solution is equal to amount of solute upon amount of solvent. The second point, there are many other ways of expressing the concentration of a solution, but here we will study only two methods. First one, the mass by mass percentage. Second one, mass by volume percentage of a solution. Mass by mass percent of solution is equal to mass of solute upon mass of solution into 100. The second one, mass by volume percent of solution is equal to mass of solute upon volume of solution into 100. What is suspension? Non-homogeneous systems like solid dispersed in liquid are called suspensions. Suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of medium. Particles of suspension are visible to the naked eyes. Here is the following reference image which shows or depicts the suspension. Properties of suspension. Suspension is a heterogeneous mixture. The particles of suspension can be seen by naked eyes. The particles of suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when left undisturbed, that is, suspension is unstable, they can be separated from the mixture by the process of filtration. What is colloidal solution? The particles of a colloid are uniformly spread throughout the solution. Due to relatively smaller size of the particle as compared to suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture. For example, milk, etc. Because of the small size of colloidal particle, we cannot see them with naked eyes, but this particle can easily scatter a beam of light visible. This is scattering of beam of light. It is called the Tyndall effect after the name of the scientist who discovered it. Here is the following reference image for the Tyndall effect. That is, the solution of copper sulfate does not show Tyndall effect, but mixture of water and milk shows the Tyndall effect. Properties of colloid. A colloid is a heterogeneous mixture. The size of particle of a colloid is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and makes its path visible. They do not settle down when left undisturbed, that is, a colloid is quite stable. They cannot be separated by the mixture by the process of filtration, special techniques called centrifugation. Here means this line means that centrifugation is only the process by which it can be filtered. The components of a colloidal solutions are dispersed phase and dispersion medium. Colloids are classified according to the state, that is, solid, liquid, gas of the dispersion medium and dispersed phase. The components of colloidal solutions are the dispersed phase and dispersing medium. Colloids are classified according to the state, solid, liquid, gas of the dispersing medium and dispersed phase. A few common examples are given in the following table on the next slide. There are common everyday life examples which can be used here, which are given in the next slide as according to your NCERT syllabus. Here are some common examples of colloids having their dispersed phase, dispersing medium, type, and the examples. Please learn it because this is so important and the questions can be asked in examination also. Now we are going to start a new topic, that is separating the components of a mixture. In this we will see that how we can separate many mixtures by the simple process. Heterogeneous mixture can be separated into their respective constituent by the simple physical methods like hand picking, sieving, filtration that we use in our daily life. Sometimes special techniques are used for separating mixtures. How we can obtain colored component dye from the blue-black ink? Fill half a beaker with water, put a wash glass on the mouth of the beaker, then put few drop of inks on the wash glass. Now start heating the beaker. We do not want to heat the ink directly. You will see that evaporation is taking place from the wash glass. Here you are taking the process of that is water bathing. Water bathing is a process in which the any material or component is evaporated or heated not directly, but it uses the force or the energy of the evaporated water or the vapor or the steam. Continue heating as the evaporation goes on. The stop heating when you do not see further changes on the wash glass. Observe carefully and record your observations. Thus, we can say that volatile component solvent from its non-volatile solute, we can separate it by the method of evaporation. Here the following reference image, which is showing the evaporation of the ink for getting the separation of the ink. How we can separate cream from the milk? Take some full cream milk in a test tube. Centrifugate it by using a centrifuging machine for 2 minutes. If a centrifuging machine is not available in your school, you can do this activity by home. You are using a milk churn used in the kitchen. If you have a milk dairy nearby, visit it and ask how they separate cream from the milk, how they make cheese paneer from the milk. Sometimes the soil particles in the liquid are very small and pass through the filter paper. They can't be used by can't be separated by the simple methods like filtration. They need a special technique called centrifugation. Centrifugation is a process in which any system is spun rapidly in the machine to get the higher density material downside and the lower density material upside. The following principles is that the denser particles are forced to bottom and lighter particles stay at the top when spun rapidly. The main applications are used in diagnostic laboratories for the blood and urine test, used in the dairies and the home to separate the butter from the cream, used in the washing machines to squeeze out the water from the wet cloths. Here the following reference image which is showing the centrifugation, and another image is showing the reference that these are the centrifugation tube which are used in this and having their above densities for this. How we can separate a mixture of two immiscible liquids? Let's try to separate the kerosene oil from the water using a separating funnel. Pour the mixture of kerosene oil and the water in separating funnel. Let it stand and disturb for some time so that separate layer of oil and water is formed. Open the stopcock for the separating funnel and pour out the lower layer of the water carefully. Close the stopcock of separating funnel as the oil reaches the stopcock. The main applications are used here is that to separate the mixture of oil and water. In the extraction of the iron from its ore, the lighter state is removed from to be by this method to leave the molten iron at the bottom in the furnace. The principle is about the miscible liquids separate out the layers of depending on the densities. Is the following reference image which is showing the separation of immiscible liquids that is having the kerosene oil and the water in it. As we studied in chapter first about the process of sublimation, the sublimation can be used here as the following examples for using to separate a mixture of salt and ammonium chloride. The sublimation means changing of any material from solid to gaseous vapor and again back from gaseous vapor to solid. Is the dye in black ink a single color? Read out the following procedures as per the NCERT, and the following things I will explain to you as I'm explaining to you. The ink that we use has the water as the solvent and the dye is soluble in it, and the water rises on the filter paper. It takes along the dye particles. Usually a dye is mixture of two or more colors. The colored component that is more soluble in water rises faster, and in this way the colors get separated. The process of separation of these components of a mixture is shown as chromatography. Chroma means in Greek means the color. The technique was first used in separation of colors, so the name was given. Chromatography is the technique used for separation of those solutes that dissolve on the same solvent. With the advancement in technology, newer techniques of chromatography being developed, you will study about the chromatography in higher classes. The main applications are to separate the colors in a dye, pigments, the natural color, drugs from the blood. How we can separate a mixture of two miscible liquids? Read out the following procedures which will be done in the experiment and follow the given apparatus, and I will explain only the lines which I am telling now. The methods is called distillation. It is used for the separating components for mixture containing two miscible liquids that boil without decomposition and have sufficient difference in the boiling point to separate a mixture of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin. Fractional distillation process is used. For example, for the separation of different gases from the air, different fractions from petroleum products, etc., the apparatus is similar to that for the distillation, except that a fractionating column is fitted in the between the distillation flask and the condenser. Here are the following reference images for the simple distillation for two miscible liquids and also the fractional distillation. Our next topic is how can we obtain different gases from the air. Here is the following reference image to show the process of obtaining gases from the air. This image is taken from the NCERT textbook, so go through it, and if you don't understand anything, ask in the comment box. How can you obtain different gases from the air? If you want oxygen from the air as 2.12, we have to separate out all the other gases present in the air. Air is compressed by increasing the pressure and then cooled by decreasing temperature to get liquid air. This liquid air is allowed to warm up slowly in the fractional distillation column and gets separated at different heights depending on the boiling points. This is the following reference image for the separation of components of air. So please study it because for drawing this figure also came in exam many times. So please stay tuned for the other notifications in this channel. How we can obtain a pure copper sulfate from an impure sample? Follow all the given processes, and after that we will come to a conclusion that by the process of crystallization we can do all the above activity. The crystallization method is used to purify solids. For example, the salt we get from the sea, water can have many impurities in it. To remove these impurities, the process of crystallization is used. Crystallization is the process that separates the pure solid forms of crystals from a solution. How we can obtain pure copper sulfate from an impure sample? Crystallization technique is better than a simple evaporation technique, as some solid composite of sugar like sugar may get cleared on heating to dryness. Some impurities may remain dissolved in solution even after filtration. On evaporating, these contaminated the solid. Applications are many of this: purification of the salt that we get from the seawater, separation of crystals of alum, that is fitkery, from impure samples. Thus, by choosing one of the above methods according to the nature of the components of a mixture, we get a pure substance. With the advancement in the technology, more methods of separation techniques have been devised. How we can pure copper sulfate from an impure solution? Some parts are left here, and this is the following figure which helps to water purification system in the water works to transport it to the home. In cities, drinking water is supplied from water works. A flow diagram of the typical works is shown in figure 2.13. This shows that the water is transported from the reservoir to the sedimentation to the loading tank to the filtration tank, from filtration tank to the chlorination tank to kill the bacteria, and after that it is supplied to the houses for the use. Physical and chemical change. Physical change is a change which can be reversed. The interconversion of states in a physical changes becomes these changes occur without a change in composition and no changes in the chemical nature of the substance. Chemical change. Chemical change is a change which cannot be reversed. The burning of paper, coal, etc. Here the main important some point is given here in the study textbook. The burning of candles show both chemical change and physical change because the wax melts and again get transferred into the wax, but the thread of the candle burnt away but didn't turn into the earlier form. Here the wax used the physical change and the thread works as the chemical change. These are the following differences given for the pure substance and the mixtures, so prepare it as well. Properties of metals and non-metals. Metals. These are sonorous, these having luster shining color, they conduct electricity and heat, they are ductile, they are malleable. Examples are gold, silver, iron, etc. Non-metals. They are non-sonorous, they having non-lustrous shining colors and found in different colors. They do not conduct electricity and heat. And non-ductile, they are non-malleable. For examples, the wood, etc. Thank you for attending the lecture.